Today's lesson is using scientific methods to investigate a problem. And it's going to be kind of fun today because we're going to look at something that happens almost every second around the Earth, and that is a meteor shoots through the atmosphere. And we're going to see if the effect of the speed of a meteorite will actually affect the size of the crater it makes. And you're going to use science investigations to do that. And we'll be getting to our book in just a second on that. So if you want, you can get these materials ready. Now, I love studying about Earth and space and rocks, and the best thing that pulls all three of these together is something called a meteorite. And I like to collect meteorites, and I have several of them. I brought a few to show you today. Here are the meteorites I brought, and these came from Arizona in a place called Diablo Canyon. And these meteorites came to Earth thousands of years ago, but a geologist found these and collected them, and now I can share them with you. And if you stop and think about this piece of rock right here, or stone, has come millions of miles through space, through our atmosphere, where it got very hot, and eventually parts of it were left over, and it actually ended up being a meteorite. So we have a meteor right here, a meteorite that we'll be able to share with you in just a second. So let me show you. Let me do a little bit of a drawing first. Okay, so this meteorite is called a meteorite. And a meteorite is something that's landed on the Earth. Now, this is not the scale, but here's the Earth. And when it landed, it probably made a crater. This meteorite here that's come millions, maybe millions of miles, and it's come through our atmosphere. And I'm going to draw our atmosphere, and this is not to scale. But as it was coming through the atmosphere, it was going very fast, and the faster it went, the more air it went, it got hotter and hotter and hotter until it probably broke up. And that's why I have all these pieces. Now, when it was out in space, it may have been much larger, and it was traveling, but since there's no air in space, it wasn't heating up. You know, I said this happens all the time around the Earth. Right now, small pieces of either stone, metal, or glass, or dust from comets or asteroids are entering the Earth's atmosphere. And most of them go so fast that because of friction, they burn up. And sometimes during the day, you see a big one, but mostly at night, you can see one shooting across the sky or falling out of the sky. And we call those falling stars or shooting stars, when really they are a meteoroid in space, a meteor as they're going through the atmosphere, and if they land on the Earth, these guys right here, they're called a meteorite. So those are some of the different ways to look at meteors, meteorites, and meteoroids, okay? In our science book on page 222, we're going to investigate, using scientific methods, how does the speed of a meteorite affect the crater it makes, okay? So in this experiment, you will create a model to find out how a meteorite's speed affects the size of the impact crater. And like all investigations, we're going to start with a question. Will meteorites that move faster make a smaller or larger crater than meteorites that move more slowly? And you're going to do a hypothesis. In fact, let's do that now. You get to choose one of three hypotheses. Write your hypothesis by circling one of these choices and finishing the sentence. Here's the sentence. If a meteorite is moving faster, then it will make a crater with a width that is, and you select A, B, or C, larger, smaller, about the same size as a crater made by a slower moving meteorite because, and you fill that in. So take a moment, think, make your selection A, B, or C, and give your reason. All right, whatever hypothesis you selected, before we go any further, we need to identify and control the variables. Remember, your model is a model of the meteorite. The flower is a model of the Earth's surface. And to make this a fair test, what are you going to keep the same each time? So on number 2, you need to list what are you going to keep the same. Are you going to use the same marble, the same steel ball, flower? I had a chance now to look at the control variables. The next is the independent variables. What is the one thing you're going to change each time? And the independent variables will probably be how high you're going to drop the ball or the marble on each time. And finally, number 4, the dependent variables, what are you going to measure? And you're going to measure how wide the width of the crater is. Before you start your experiment, your investigation, I want to make sure that you completely fill out this page, make your drawing of your model here, and write your steps that you're going to do right here and here. This will probably take you a bit of time to get set up. Go ahead and complete page 222 and 223 before we move any further. Captured a rare event that streaked across the sky. It was a meteorite that crashed into a lake, and it went across the sky. So I have some video I'd like to show you. Now, no one was hurt by the meteorite, but several people ended up going to the hospital because of the sonic boom. It was going so fast that the air expanded and clapped back together, and that knocked out windows. So this is some amazing footage here. This is a picture of it going across the sky and getting so hot because of friction. I imagine people had no idea what was going on because it was a dark sky when it came across. Here's some people in an office, and the sonic boom blew part of the window out. And you can see the contrail going across the sky. This is actually where, as it's burning up through the atmosphere, it's leaving behind, it knocks this door open in this factory. So it wasn't the meteorite that hurt anyone. It was actually the sonic boom. I like this one right here. Here's the back of a bus. You can see it in the reflection of the bus going across the sky. And I guess one of my favorites is right here towards the end. You can see up in the sky the contrail as it went overhead. So meteorites happen all the time, but usually not this large, and usually not during the day. And you can see it here in the sky. Pretty amazing, pretty amazing. Okay, so, you know, I'm a science teacher and I love sharing things with kids, and I'm always asking people, hey, do you have anything free? And I need 30 of them. This I got when I was visiting a NASA center. This was going to be thrown away. This book is an atlas of all of the images, a map that was pictures that were taken of the moon when we studied the moon. And it's the Lunar Orbiter Photographic Atlas of the moon. And it shows, it's kind of in bad shape, but it shows how and when and where all of the pictures of the moon, and especially craters of the moon, on all the different flybys. So you can see how the spaceship flew and photographed this parts of the moon. And you see some parts of the moon, there's smaller craters, large craters, and as you go through this, you can see that the moon is filled with craters, just filled with them. Why? No atmosphere. And secondly, not only is there no atmosphere, on Earth, when we have an impact crater, our forces of nature, our wind, water, and ice, erosion, removes most of the traces of the crater. Just like the craters you're making with your flour, if the wind came, don't do that because I don't want you blowing flour everywhere, but if the wind came, you would start to see erosion by wind, water, and ice. But on the moon, there is no atmosphere, and so these craters have been here for such a long time. Can you imagine if you're in a spaceship flying across the surface of the moon? Good stuff. I'll see you next time. Hope you enjoyed using scientific methods to determine if the speed of a meteor affects the crater it makes. Good luck.